Adding applications. In this tutorial, we will be focusing on the applications module. We will be looking in particular at the applications that you will most likely use and how you could add these applications to your own simulations. The applications module basically has a number of built-in applications that we can actually add to our own simulations. But generally, we tend to just use a subset of those applications. I've listed here just a few of those that I've particularly have used in my experience with NS3. For instance, we have something called an on-off application, which simply has an on period and an off period. And during the on period, packets are transmitted, and during the off period, the application is silent. And this pattern repeats itself once the application is up and running. Next, we have an application called the packet sync, and what it simply does is receive packets that are sent towards it. And then we have the UDP trace client, which is important if we want to use a video trace file to actually send video data from one location to another. And then we have the UDP echo client and the UDP echo server. And what the UDP echo client simply does, it sends UDP packets to a UDP echo server, and the UDP echo server would simply echo those packets back to the client. And then finally we have the UDP client and the UDP server, which are similar to the UDP echo client and UDP echo server. The only real difference is that the UDP server does not echo the packet back to the actual client. And as before, if you remember during our tutorials when we built some simple networks in NS3, we saw how important the use of helpers were. So we should not be surprised then that the applications module also contains helper classes that really simplify the addition and the configuration of our applications. So let's hop across to the internet and look at the online documentation. Let us look at a few of these applications that we just talked about. So let's look at the UDP client. So this is the UDP client class reference, and you can see there is a constructor for creating a UDP client, and we can set the remote address. So that is the address of the UDP server as well as the port. And if you scroll down, let's see if you could find any attributes. So there are several attributes we could set for a UDP client. For instance, like the maximum number of packets the application will send, and this is the initial value of 100. And we could look at the interval between the packets. We could of course set the remote address, the remote port, the size of the packets, and of course we have the start time and stop time of the application. But generally we will not actually interact directly with a UDP client. To make our life simple, we would actually use the UDP client helper. So you can make use of the helper class. So you can see here in the constructor, one of them we could actually, well, a couple of them actually, we can see that we could provide the IP address of the remote server as well as the port. And of course these two values will be used to set the attributes that we just looked at. And then we could, if we scroll on a bit, well, there's the install function here. Alright, and we can see that we can pass a node container with the nodes that we want this particular application to be installed on, and it will actually install a UDP client on each node within this particular node container. And that is basically what we can use the helper for. And we could also see we have a set attribute function, and we saw how we could have used this in the tutorial on configuration. So we can actually set the various attributes on the UDP client by specifying the name of the attribute and the actual class that we use to set the value of the attribute. And that is basically as simple as it is. Most of the applications have the same setup. For instance, if I could look at, let's look at a UDP echo client, and you'll see a similar um, structure. So we have a constructor, and there are several methods. For instance, this has a set remote as well. And if you look at the attributes, you can see there are several attributes that could be set. And no doubt, if I go over to UDP Echo Client Helper, I would expect to see a constructor that allows me to pass in a few parameters that I can initially set up. I would of course see an install or several install methods in this case, and I should see a set attribute function that allows me to set the attributes on the underlying UDP Echo client. And that is the general structure of these type of applications. So when we actually add these applications to our own simulations, we will most likely be using the helper class to actually ease our configuration and setup of those applications. Now that we have been introduced to some of the applications in NS3, I would just like to talk a little bit more about each one before we proceed. Because it's important, yes, to know that the applications exist, but it's even more important to understand the capabilities of each application and also to understand how they should be used and in what combination. Because you see, some of the applications actually source packets, which means that they transmit packets, whereas some of the applications can actually sync packets, which means they only receive packets. So take for instance, here we have the on-off application, and of course from the diagram you can see that there is an on time and an off time. We can see that we could determine the interval between packets based on the packet size and the data rate. And all of the things I've just mentioned are actually attributes of the on-off application. So we can see that the application actually generates this on-off pattern, and within the on period it would send packets at a constant rate. So let's just go over to the online documentation. Let's take a little look at the on-off application. Okay, it's actually here already, so I guess I could just type, and I could click on on-off application, and there we have the class reference. So you can see here, if I scroll down to the attributes, so we can see the data rate that I just mentioned, we can see the packet size, and we can see things like the remote address, the on time and off time. We can see also, for instance, the protocol, whether the application is going to be sending TCP or UDP packets, and by default it's UDP. And I just want to highlight here though that if you notice, for the on time and the off time, there is a random variable that you can actually use to specify the on time. By default, the on time and off time would be constant, but you can actually change that and have the on time and off time vary for each cycle. And that is very important if we want to, let's say for instance, model something like voice traffic. But we could talk a bit more about that probably at another time. Let's talk a bit about the packet sync application. And as mentioned before, that the packet sync application would actually consume traffic that is sent to IP address and port, and it was written to basically complement the on-off application. But of course you can use it for any application that you wish. So in the diagram here I have an on-off application, and you can see there are several attributes that we could actually configure. And if I were to send traffic from my on-off application through my simulated network, it would arrive at the destination node, which has the packaging application running on it, and those packets would be received on a receive socket. So for the attributes for the packet sync, I can of course set the protocol, whether it's TCP or UDP, and that will dictate what type of sockets will be created. And of course, there's something called local, which specifies the address that I'm actually going to bind to this receive socket. So let's take a look at the documentation, because I want to clear up a few things before I move on. So let's look at the packet sync. So you can see here that we have a packet sync class reference. And let's look at, for instance, the attributes. So you can see that the attribute called local is the address on which to bind the receive socket. And we can see here that it takes, it's set with an address value and it takes an address. Now you would probably notice as we go into the live programming session that an address could actually take on different forms. So you have to be careful and be able to determine which form this address should be in. Now it tells us here that the constructor specifies the address, which is an IP address and a port. And you know that an IP address and a port essentially is a socket. So this address here would be some type of socket address rather than just simply being an IPv4 address. If you were to try to set an IPv4 address here, the application most likely would not work. So just bear that in mind. And the constructor they're speaking here of most likely is the constructor for the packet sync helper, because you can see it takes the protocol as well as an address. In this case, this address would be some sort of socket address. I mean, particularly, I can show you what it looks like. I think it's an inet socket address. And don't worry, we will see more of this in a little while. Inet, can't even spell. Socket address. Okay, there it is. So you can see that basically it's a type of address, because the address class is basically, it's a polymorphic class, which means basically that it could exist in different forms. So we can see here that for the first constructor for socket address, inet socket address, it actually would take the IPv4 address and it would take the port. So we would actually use this to actually create an inet socket address, which we would actually pass as the address to our packet sync application. In the case of the UDP client, this application transmits UDP packets carrying a 32-bit sequence number and a 64-bit timestamp. So the UDP server would use this sequence number to actually determine if a packet was lost, and it would use the 64-bit timestamp to actually determine the packet delay. So if I were to send packets from my UDP client here through my simulated network to the UDP server, I can actually determine how long did the packets take from source all the way to destination. And we can see here that we have several attributes that we could set on the UDP client. For instance, the remote address and the remote port. And you would realize that most likely this address in this case would be an IPv4 address, since we are specifying the port separately. And over here on the server, we specify the port on which the server would listen to for incoming packets. The UDP Echo client and UDP Echo server applications are quite similar to the UDP client and UDP server. The only real difference here is that they both can source and sync packets. So for instance, the UDP Echo client could transmit a UDP packet to a remote server, which is echoed by the remote server and received by the UDP Echo client application. And in the case of the UDP Echo server, it could receive a UDP packet from the remote client, and then it would actually send that packet back to the remote client. So they both actually send and receive. And we can see at the bottom of the diagram, we also have the attributes that we can set on each one. So we have the remote address, which is the address of the UDP Echo server. We have things like the packet size, the interval between each packet, and we can also set the remote port. And on the server side of it, we can set the port that the application would actually listen to for incoming packets from the actual UDP Echo client. So finally, we have the UDP Trace client. And this is a really cool application. I've used it a few times myself. And we can use it to load a video trace file and send packets to a remote host. So in the diagram, you can see a UDP Trace client, and we can see the attributes we could set. We have the remote address, which is the address of the remote host. We have the remote port, which is the port that we are sending our video data to. And then we have the trace file name, which specifies the trace file that we're going to read the video data from. The video data basically consists of three types of frames. There are I, P, and B frames, and those frames are grouped together in a particular format, which is called a group of pictures. And if you look at the snippet of code that I have displayed, it's taken from the UDP trace client.cc file. You will see what that group of pictures or that formatting looks like. So there's a pattern of I, P, and B frames, and that pattern is repeated generally throughout a video trace file. So if we take a look at a video trace file, we can see that we have the frame type, and we can see the repeating pattern. If we look at the pattern of I, P, and B frames, we could spot a group of pictures here. We have I, PBB, PBB, and PBB, and it's generally repeated if we were to look through the rest of the trace file. We can also see the time at which the particular frame was sent by the application, and we can see the length of that frame in terms of bytes. So this is really the general format of what that trace file would look like, and this is what we would use with the UDP trace client to send video data to a particular remote host. So now that I've introduced you to some of the applications in NS3, I'm personally really glad that's over, because I don't know about you, but I'm anxious to actually get started doing some programming. But before we do that, we need to at least plan out what our activities will be. And I have a diagram that should be familiar to you. It's the same one we've been using for the past couple of tutorials, and we will also be using this throughout the tutorial series. Of course, as we go along, you would see it eventually grow as we add more and more items to this particular diagram. So right now we have some applications that have been added to a few nodes. For instance, workstation 1 has a UDP Echo client and an on-off application added to it. The file server has a UDP server. The workstation number 2 has a UDP client and a packet sync. And the printer has a UDP server. So we can see for flow 1, which is the red flow, we can see here that packets are being sent across the network, and they're sent to the UDP Echo server application on the file server, and those packets are originating from the UDP Echo client. We also can see here that the on-off application is sending packets. This would be flow number 2, the orange flow, and those packets are being sent to a packet sync application that would be added to workstation number 2. And lastly, on subnet 5, we can see we have a UDP client application, which is flow number 3, the green flow, where we can see packets are being actually sent to the printer node, which has a UDP server application running on it. So this is what we wish to achieve in this programming session, to install those applications on those various nodes. So let's get started with our live programming session. So I'm going to enter into the NS3 folder and navigate down to the ns3.14.1 folder. I'm going to right click in the open area and open up a terminal. And then I'm going to go into the Scratch folder, and the file that we are going to use today is tutorial7.cc. It's basically the file that has all the code that we had done in the last programming session, which was tutorial number 6. We did configuration in that tutorial, and you can see all of our configuration is still here. So what we're going to do this time is simply we're going to add some applications. So I'm going to create a little comment here, add in applications. Lovely. And then what I want to do actually, let me just save that, is I want to start off first with flow number 1. So we are going to be adding an application here to the file server, which is a UDP echo server. And we are going to add on workstation 1 a UDP echo client. So we are going to send packets from the client towards the server, and of course the server will echo those packets back to our client. So first of all, I need to find out what is the IP address for this particular node, and I need to also specify a port number that the server will actually listen to for any incoming packets. And to do that, let's just clear up a few things first, because I know you might be a little bit rusty. So we have here subnet number 5, and what we did is that we created a node container to hold the nodes within this subnet. So the first node that would have been added to that node container would be router number 3. Then we added the branch node container, which had these 3 nodes, and therefore we would have had 4 nodes added to our node container. So within that node container called subnet number 5, there would be 4 nodes, and the nodes would be indexed starting from 0. So router number 3 would be at an index of 0, and not router, but rather file server. This file server would be at an index of 1, the workstation at an index of 2, and finally the printer would be at an index of 3. So we are interested in this guy. So we know he's at an index of 1 within our subnet. So let's go back to our code. So you notice here, this is what we did before. We had a node container created. We added the router, added the other 3 nodes, and therefore when we pass that node container to the install method of our CSMA helper, we know that we would have had some net devices that would be installed on each node within this node container. So the subnet 5 devices, this particular net device container would have net devices in a particular order. At index 0 would be the net device that would be on router number 3, and at index 1 would be the net device for our file server. And when we pass this guy, the subnet 5 devices, into the assign method, when we were doing the addressing, we know that the net device that is at an index of 1 in the subnet 5 devices, which is the one that's associated with the file server, would get an address of 10.1.5.2, because the first one would get 10.1.5.1, and then the second one will get 10.1.5.2. But more importantly for us, we are really interested in the index within this IPv4 interface container. So the index is not going to change. It's also going to be at index 1 within this subnet 5 interfaces, this IPv4 interface container. So what we will do then is simply go ahead and create an IPv4 address. And don't worry if you are a little confused about that. I'll advise you to go back to our previous tutorials and look at device addressing, look at node addressing, node indexing rather, and look at how we assign IP addresses to a particular net device. So I'm going to call this IPv4 address. I'm going to call this address fs_address. So it's the IPv4 address for our file server. I'm going to make use of this interface container here. and I'm going to call the get address function because I want the address, and I need to specify the index within that container. I know it's index 1, and that will give us the IP address for that particular node. Now we need to get, or rather we need to create another variable to uint16 underscore t. This is a 16-bit unsigned integer, and this will be the port. This is the port number, and we will give it a port number of, let's say, 4500. So far we have the IPv4 address, and we have the port number for that particular node, which is the file server. So now we're going to go ahead now and actually go ahead and install the UDP Echo client on the workstation 1 node. So I'm going to go into, let's go into the NFV source code, and I'm going to actually look for the UDP Echo client helper. So it's in the applications module, and we're going into the helper folder. Let's see if we could find it. So we're looking for UDP Echo helper. Alright, so that's over here. I'm going to actually look at the .h file, I believe it is. So I can see here, I'm looking for the constructor. This is the UDP Echo server. Where is the Echo client? Let me scroll along a bit and see if it's, there it is. It's a little bit further down. So we can see here I have several constructors, and I want to be able to create one that takes IPv4 address and a port. So that is the one I'm going to use. So going back to my code, but that's not my code. There it is. So I'm going to actually create here a UDP Echo client helper. But that looks okay. And I'm going to call it workstation. I'm going to use WKS1 Echo, and I'm going to actually pass to it now those two parameters. One would be the IPv4 address that we created earlier, because that is the address of the remote host. In this case, it's file server, the file server node, and then we need to actually pass the port. So let me just copy that. Voila. So that's as simple as it is. We just created a UDP Echo client helper. Now we actually have to go ahead and add that application to the particular node. So we're going to be using something called an application container, and I think you can guess from the name what it does. Yeah, it actually contains applications. So we're going to call this WKS1 Echo app, and we're going to use an install method. So we're going to use the UDP Echo client helper object. I'm feeling lazy today, so I'm going to just copy and paste, and we're going to call the install function. There should be no surprise to you. You've seen this done before when we created nodes. So you can have an idea of what the install function actually does. But what we actually need to pass to this function, we need to actually pass the node that is going to have this application installed on it. And we know that is workstation number 1. If we go back to our code, if we scroll up a little bit, when we did the original creation of these nodes, we see that we had the host node container that just had one node in it, which was the file. This is the workstation 1 node, So to get that node, we're going to have to actually use that node container and call the get function and specify the index of that node. Well, of course, there's only one node inside of it, so it's going to be at that index 0. So there we have actually now installed on the workstation 1 node a UDP Echo Client application. And if you wanted to get that application, we could get it through the application container. So now we want to do is something that is very important, of course. Now that we have actually created the application, we would actually want to start and stop it. So we are going to make use of the application container. Well, we are going to call the start and stop methods. Oops, that's not stop. Silly me. And we have to specify as a parameter a time object. So I'm going to use this function called seconds, which returns a time object. And I'm going to specify that the application starts at 1 second and that it finishes, let's make it finish at 10 seconds. And that is as simple as it is to install the UDP Echo client on a particular node. So we created the UDP Echo client helper object, which we were able to pass the IP address and pass the port, and then we install on the particular node the application, and then we simply specify when we want it to start and when we actually want the application to stop. Okay, so what we have done so far is that we have installed a UDP Echo Client application on workstation number 1, and we have told it that the server is located at file server, and we have specified a port. So what we need to do now is actually go ahead and create or actually add the UDP Echo server application to the file server node. So let's go ahead and do that. So I'm going to need to obviously create a UDP Echo server. I'm going to need to create a UDP Echo server helper object that will assist us in creating our UDP Echo server application. So I'm going to call this one FS for file server. And what we actually would need is a port number. So where is my documentation? So I think if I scroll back up, I should be able to find the server. There it is. So we need a port number, and that is the port number that we would have specified earlier. So I'm just going to copy it. So it's going to listen on this particular port for incoming packets. And once we have created our helper, we can go ahead now and install that particular application on the node. So just as before, we're going to need a application container, and I'm going to call this one fs underscore app, and using our helper we are going to call the install function, and again we need to specify a particular node, and this is the node on which the application is going to be installed on. And if you look at our node container here, we have a node container called subnet 5, which has the nodes in that particular subnet, and we want to get the node that is at an index of 1. So we have just installed the application on the file server. Of course, now we need to actually start and stop the application. So I'm going to use the application container, and I'm going to call the start method, and I'm going to specify a time. So I'm going to create a time object here using the seconds function, and I'm going to start it at 1 second. And of course I'm going to do the same thing for the stop method. So I'm going to specify it to stop. So we're going to specify it to stop at a time of 10 seconds. So that we just set that up 10.0. So there you have it. So what we just done is created those two applications, installed the Echo client on workstation number 1, and install Echo server on the file server. And that is as easy as it is. Installing applications are very simple. Once you take your time to consult the documentation and make sure you set up the correct configuration for these applications. It's really a breeze, and there's actually nothing really to it. So before we go ahead and install the applications for flow number 2, let us go ahead and just compile this to make sure that we are okay. So I'm typing /waf in our terminal. Okay, so it says on line 171 that the UDP Echo client helper was not declared in the scope. So that means that the compiler doesn't know about it. So I'm pretty sure I know what the problem is, because in our haste we did not include the applications module. So let me go ahead and do that right now. And s3 slash it's applications dash module dot h. Okay, so let's go ahead and recompile. Hopefully everything is okay at this point in time. Guess not. So let's see line 175. Oh, I see, this should be seconds. Alright, so let's go and fix that. 175 seconds. Alright, and let's recompile again. I did it again, 179. Alright, line 179. Oh, it's an actual 180 as well. Okay, I think we should be cooking with gas now. So let's recompile and hope that everything goes fine. Excellent. So we have been able to compile our file, and we can move on now to actually creating the applications for flow number 2. So for flow number 2, we have at the source node, we will have an on-off application sending packets to the destination node, which is workstation number 2, and the application there would be a packet sync application. So let's go to our documentation and take a look at let's look at the packet sync application. Packet sync, and why is my cap locks on? So let's look at the packet sync helper actually. So first of all, we can see it takes a protocol and also an address. And know that when we look back at the packet sync application as before, we know that that address is actually really a combination of an IP address and a port number, which really is a socket address. So what I'll do first of all is create the IP address and port number. So let's go ahead and do that. So I'm going to need an IPv4 address, and I'm going to call it, what should I call it? Yeah, WKS2 underscore address. So we are looking at the IP address for that'll be workstation number 2. and I'm going to use this portion up here, but of course I'm going to specify a different index, and that index is an index of 2. So if you notice here that the file server was at an index of 1 in the node container called subnet 5, and therefore this one, which is next, would be at index of 2, and all that would have translated right down to the interface container. So of course it's going to be at an index of 2 within the interface container. So once we have the IP address, we now need a port number. So I'm going to create a UN60_T variable. This is going to be WKS2_port, and let's give it a value of 7250. And then we now need to create an INET socket address. So let's just go ahead and create that INET socket address. Let's see what it takes. I'm sure you know what it takes, but let's for all benefit, let's just look at what it actually takes. INET socket address, there it is. Right, so it takes an IPv4 address and a port number. So let's go and fix that. So we're going to pass into it workstation 2's address, and we are also going to pass the port that is going to listen to for any incoming packets. So we have created the IPv4 address, we created the port number, and now we have actually created the INET socket address that we will use in both of the applications, both the packet sync as well as the on-off application. I'm going to create now an on-off application. So I'm going to use a helper. So I'm going to create an on-off helper. I'm going to call it WKS1_on-off. And I need to specify a protocol. So I'm going to be using UDP. So I'm going to say NS3::, and we're going to use the UDP socket factory. So we're going to use UDP, and we're going to create UDP sockets. So I would like you in your spare time to actually go and look at what a UDP socket factory does. And then I'm going to now specify an INET socket address. Let's see. Okay, I actually created this INET socket address a while ago, and you didn't even tell me that I did not actually create a name for the object. What kind of students you are? So let me go ahead and do that. You all left me to the slaughter there. Just imagine if I actually compiled what it would have actually said. So let's see. What's a good name? Okay, let's call it WKS2, and I'll call it socket_address. Alright, and now we could go ahead and copy that socket address, and we will place it right here. So we have created now our on-off helper, and we have specified the protocol that we're going to be using. It's UDP, and we're going to be creating UDP sockets, and we have also specified a socket address. So now we need to go ahead and create an application container, and I guess you know exactly what I'm going to do next. Let's call this one WKS1_on-off app, and we use our helper, and that will create for us, using the install method, our application. And we know this is going on workstation number 1, which is going to be host.get 0. That's the node container it's in. And once we have done that, we can go ahead now and actually use the application container, and we can call the start and stop methods. So I'm going to specify a time here of 1 second for it to start, and I also want it to stop at a similar time to the other applications. So let's get it to stop at 10 seconds. So there you have it, folks. We have created our on-off application on workstation number 1. So that's here, and we are now left to create a packet sync application on workstation number 2. So let's go back to the code and let's actually get that done. Right, so we're going to create a packet sync application using its helper. So of course we're going to create a packet sync helper object. My goodness, what's wrong with me? Wow. Okay, packet sync helper, right? And I'm going to give it a name. Yeah, sometimes it's like that. We're going to call it WKS2 sync, and of course we're going to specify a protocol as well as the actual socket. So it's going to be the same thing as this, because the address that we are passing here, which is the socket address, is actually the socket address that we're going to bind to on this particular node. So both of them are actually using UDP and creating UDP sockets, and both of them are actually using the same address. So the on-off helper is actually going to send packets to that particular address, which has that IP address and port associated with it, and the packet sync is actually going to listen for incoming packets on this port here, as well as on the IP address that we specified. So next we have to go and do our favorite task, which is create an application container. Application container, and we will call it WKS. Okay, that didn't look right. WKS 2. Call it sync app, and yeah, let's call, yeah, that's a good name. So let's actually go ahead and use our application helper. So let's call the install method, and who are we installing this one on? So it's going to be, let's check. Yes, it's workstation 2. So these 3 nodes here would have been in the branch node container. Let's see. Please don't take my word for it. Yes, the branch node container, and we want to actually use that to specify the particular node. Now of course we could also use the subnet 5 node container as well. So we have a couple choices there, but I'll use the branch node container in this case. And we are going to call the get method and specify index, and in the branch container it's going to be at an index of 1. Of course if we had used the subnet 5 node container, it would have been at an index of 2, because this one would have come first. So you would have gotten 0, 1, 2, then 3. But since we're using this node container here, it's going to be 0, 1. Alright, so please get comfortable with actually understanding how the indexing is actually done. It's very key if you're going to actually do any sort of programming in NS3. So what have we done so far? Okay, so we have the application container, and now we want to go ahead and I want to use it to actually specify the start and stop time for our application. So I'm calling the start function here, and let us go ahead and specify seconds to create a time object. Again, I'm going to use value of 1 second, and then I'm going to do the same thing over here with the stop method, and this one would be seconds, and I'm going to stop it at 10 seconds. So there you have it, folks. We have created our applications for flow number 2. We have the on-off application as well as the packet sync application, both created using application helpers. Okay, so let us compile our code and see if we made any errors. Okay, so at 193 it is saying that WK2 sync was not declared. So let's go and see what that is. 193. So we have WK. Okay, that's probably looking like a common key, is it? Yes, it was a common key. So let's compile again. Okay, so we are all right there. So now we need to go ahead and do the application flow, which would be flow number 3. It is, yes. So that's the green flow. So it's a short flow. It's coming from workstation 2, and it's going to terminate on the printer. And we can see that it's a UDP client for the source application, and at the destination application we have a UDP server. So let's go to our documentation and let's look up the UDP client and server. UDP client and server. Right, so let's tackle the helper. Alright, so it's going to take a IPv4 address as well as a port number. So let's get started with that one first. So I need to create an IPv4 address. So I'm going to create IPv4 address. And what am I going to call this one? Okay, let's call it PRT for printer. So PRT address. And what are we going to use this time? So let's go ahead and copy this piece of code here. And of course, this time the index is going to be an index of 3. And now we are going to go ahead and create a port number. So it's a uint 16 underscore t, and we are going to probably call it, let's call it PRT underscore port. Leave that as a common P. And what value should we use? Let's use one that we haven't used yet, of course. So let's use 2560, a nice weird looking one. And then we have to go ahead and actually create our helper. So let's create the helper class. UDP, what's wrong with me today? UDP helper. My goodness. Now this is your fault, eh? Okay, so let's see. We have a UDP helper, and actually we need a client helper. Yeah, that's what we want to create. and we will name this one WKS2 UDP. Let's just call it UDP. Alright, and we need to specify the IP address. So this is the remote port because it's actually trying to hook up with the printer, and we need to specify the port that we want to connect to the printer, which is PRT underscore port. And once we have done that, we can go ahead and create our application container, and let's call this WKS2 UDP app. So we will use the helper as usual and call the install method, and we have to tell it which node to install this application on. This is for workstation number 2, so we'll use the branch container. Okay, that's not branch.get, and the index we need to specify would be, this would be 0 and this would be 1. Alright, so actually let's just make sure we are doing that correctly. So yes, it would be 1. Alright, so where's that? So we specify index of 1, and then we need to go ahead and start and stop the application. So let's do that. Start and specify time, seconds, and we're going to use a value of 1 second, and then we're going to stop it. We're going to stop it at a time of 10 seconds, just like the others. Alright, so let's save that. So let's go ahead and do the UDP server application. So I'm going to, let's go ahead and create a UDP server helper. Okay, that is not spelled correctly. Helper, so a capital H. So I'm going to call it PRT. And what do we need here? Well, what we actually need is the port. So I'm going to pass the port number into the constructor, and then I'm going to create an application container, which I'm sure you knew I was going to do anyway, and I'm going to call this one PRT underscore app, and I'm going to use the install function from the helper to install the application on the node, and the node is going to be branch.get, and the index is going to be an index of 2. So if you look over here, we can see that the file server would be at an index of 0 in the branch node container, workstation 2 at an index of 1, and the printer at an index of 2. So we have created so far the helper as well as an application container, and now I want to use that application container, and I'm actually going to go ahead and call the start and stop functions. Oops. And I'm going to specify a time. So it's going to be seconds, and I want 1 second. This is the time when I'm going to start the application. I'm going to stop it at a time of 10 seconds. So there you have it, folks. I have just created the UDP client, and the DP server application. So the client is actually going to send packets to the IP address of the server, which is the printer node, and is going to send it at a particular port. In this case, it's 2560, and the server is going to listen on that port for packets coming from the source, which is the client application. So we have created our three flows, and we have set up our applications on the different nodes that we intended to. So I just want to be able, at this point in time, let me just save this file and let me go ahead and compile it. Okay, so we have a few errors on 197. Okay, I can see I spelled this wrong. 197. Okay, this is IP. Should be a capital I actually. What else did we do wrong? And 197. Okay, well, that's as a result of this error. And a 200 PRT underscore address was not declared. So let me just go up here, save this. And at 200 we have what? PRT underscore address. Okay, that is a result of this not actually compiling. So let's go ahead and compile. Alright, so we have a 202 application container. It has no member called stat. And that's because it really doesn't have a member called stat. It needs a capital S. Let's compile that. And there you have it, folks. So we have successfully compiled our application.